that ideal ammeter has zero resistance and it should always be connected in series. Ammeters are always to be connected in series. And to reduce the error, the resistance of the ammeter should be more or less. To make it less, sometimes we connect or we often connect a small resistance called shunt in parallel. Taki summary the ammeter top. Is that okay? Sure. આ બધું જ ચેપ્ટર 4 માં છે એવું ન વિચારતા કે આ તો જેડબલ્યુ માટે જ આપણે લાઈટલી લેશું તો ચાલશે નહીં ચાલે ચેપ્ટર 4 માં ટેક્સ્ટબુક માં આપ્યું છે. Is that okay? So we will have to do it sincerely. ત્યારે એવું નહીં કરો right in chapter 4. Now next one, voltmeter. Voltmeter नहीं, okay, voltmeter. All right. So what is the purpose of a voltmeter? To measure voltage. Is that okay? Purpose of voltmeter is to measure voltage. Right. So measures voltage, and it is always connected in parallel to the device. It is always connected in parallel to the device whose voltage you want to measure. Whose voltage you want to measure. Right? So these are two important simple ideas actually. Okay. कहीं याद रखो पड़े हुए नहीं तो common sense हो, right? So have a look at this kind of circuit. Suppose this is, let's say, 10 ohm resistor, and this is a battery or cell with 12 volt and 2 ohm, right? And I want to first of all theoretically calculate how much is the voltage for this resistor. Can you find it? Theoretically calculate how much would be the voltage for this resistor. How do you find voltage for a resistor? V equal to I, Ohm's law. Correct or not? Clear? So do it. Current find करो. कितना current आता है? वो विचार करो. भूल गया बेटे. How much is the current? 12 volt, 10 ohm, 2 ohm. How much is the current? તમે એક બે દિવસ નો ભણો ને તે બધું ભૂલી જાય છે તમારું. કેમ એવું થાય? 1 ampere. Is that clear or not clear? Yes. Sure. The current is 1 ampere. Okay, now the voltage is what? 10 volt. Understood or not understood? Sure. So between A point and B point there is a potential difference of 10 volt. Clear? A theoretical calculation है ना, we have not measured it. Calculate it. Now let's say we want to measure it. So we will connect a voltmeter. What will we connect? A voltmeter. And where will we connect it? In parallel to the device across which you want to measure. So I want to measure the voltage for this resistor. Then a parallel में लगाओ. Did you understand? This is the symbol of voltmeter. V. Circle V. Got it? I will take it. बाकी circuit same. Okay. So 12 volt, 2 ohm. Circuit diagram is clear to you. Where have we connected the voltmeter? Parallel to the device for which we want to find voltage. And voltage find what? A and B parallel. Okay. Now, this voltmeter, it will obviously be made up of some materials, etc., etc. So it will have some resistance. Yes or no? Yes. For example, its resistance is RV. RV for resistance of the voltmeter. Okay. So can you now find out the current in this circuit? Will it be 1 ampere? No. Will it be 1 ampere? No, 1 ampere नहीं आएगा. क्या? क्या 1 नहीं आएगा? અહીંયા 1 ampere, I 1 ampere नहीं. અહીંયા ભલે 1 એમ્પિયર નો હોય I understand અહીંયા will this current be 1 ampere? Yes or no?
Yes.
Who says yes? Who says no? Okay, it's not 1 ampere. If you connect something in parallel, આનો resistance change નથી જાય equivalent. પહેલા કેટલું resistance હતું 10. હવે આ 10 અને Rv લખ્યું ને, it is not 10, correct or not? The two things are in parallel. When you simplify, clear or not? No, so what will be equivalent of these two? 10 Rv upon 10 yes. So now this whole thing behaves as R dash. This whole thing behaves as R dash. समझ पाई कि नहीं? Yes or no? Sure. Correct. And what is this R dash? What is this R dash? Yes. So current flowing now in this circuit would be 12 upon R dash plus 2. Yes or no? Why R dash plus 2? Because this and this can be considered to be like in series. And only formula. Okay, done. Right, 12 upon R dash plus 2. Now, what is R dash? What is R dash? अब इन parallel है ना तो क्या है? 10 RV upon 10 plus RV plus 2. So, is this the same as it was here earlier? Our case my I is equal to 12 upon 10 plus 2. Is that same as this? Current change here? Clear or not clear? The current has changed. Understood? Sure. You can think of it qualitatively also. When you connect something in parallel, the resistance always decreases. Equivalent resistance will always decrease. Is that okay? So our 10 was in it, what you think? If it was 10 earlier, now it is what? Less than 10. Are being equivalent. Let's take that. Suppose RV value is, let's say 40. Put 40. See what we do. Put 40. Hurry up. Done. And it is
12 by 10. 1.2.
This is going to be 8 plus 2. Clear or not clear? Yes or no? 40 upon 50. Take it 8. Sure. So this will be 1.2 ampere or 6 by 50. Is this clear? Clear or not clear? Sure. Okay. Current to change, no problem. What will be the voltage between A and B now in this circuit? Okay, આ boundary છે આ જૂનું ભૂલી જાઓ આમાં તો 10 volt આવતું. What would be the voltage here for any of them? A B છે એટલે આનો voltage આનો voltage they same જ. That's why we always connect voltmeter in parallel. I hope that makes sense to you. Voltmeter measures the voltage between these two points. અહીંયા A and B. So whether it's this resistor or for this voltmeter, it measures the same. So our voltage કેટલો આવશે VAB? How to find VAB? This is A and this is B. Do you agree with me? Yes or no? યાદ તો છે ને કેપિટલ સ્ટાર્ટિંગ માં એટલે સમ સોલ્વ કરતા હતા. So these are in parallel. એટલે આવી ગયો. હવે વોલ્ટેજ શું હશે VAB કરો? How much current is flowing here? 1.2. Okay. Into how much is the resistance? R dash. R dash છે ને resistance કે નથી? સમજ નથી પડતી લાગતી મને એવું લાગે. સમજ પડે છે શું ચાલે? Current has changed. This resistance is also not 10 now because these two are in parallel. समझ पड़ी कि नहीं? So ultimately this R dash is 8 if we take RB as 40. Okay, and then this is going to be 1.2 into 2. Current 1.2. Resistance how much? 8. So what should I write? Final answer. 9.6. What are we seeing? Ammeter मतलब तो ये होते हैं ना nature is fooling us, isn't it? Theoretically calculate करो तो 10 volt है, measure करवा जाओ तो चेंज हो जाए. Is that clear or not clear? Sure. Understood this? So is there an error? Yes or no? Error came by because this has resistance 40. So because of that 40 and 10 make equivalent 8, not 10. કેટલા 10 હતું ને પણ હવે આ 8 થઈ. That means properties of circuit have changed. By trying to connect a voltmeter which can measure it, you are changing the resistance. Resistance change hai to current change ho jayega. Current change ho to voltage change. Working? Sure or not sure? ये उसका काम था ये समझो. This battery has a terminal voltage. E जाते हैं ना VAB. Do you realize VAB is the terminal voltage of this battery? What's the formula of terminal voltage? Epsilon minus I small r. If current is more, terminal voltage is. If current is more, terminal voltage is less. Current वधी गयो. કેટલા કેટલો કરંટ? 1 amp. હવે કેટલો કરંટ? 1 amp. કરંટ વધી ગયો. That means terminal voltage will decrease. Is that fine? Okay, that is what has happened. Now why did current increase? यहाँ problem है ना, why did current increase? If current would not have increased, then would there be a problem? So why did current increase? Because this resistance together becomes smaller than 10. Make sense? So એવું કઈ કરી શકે? So that resistance doesn't become smaller. You can think of it in another way. What is happening is that now when current flows, some of the current flows here and some of the current flows here. એટલે extra current flow. Does that make sense to you? Yes. Pehla M 1 ampere flow. Now when both of these are connected, there is an increase in current, right? Is that okay? There is an increase in current. More current is flowing. Extra current is flowing. So the only way to stop this problem is that current should not flow here. અહીંયા current flow ન થાય તો વાંધો ના આવે. Let's see how. Current will come from here. Okay. અને આ બાજુ no. Go back. Is it fine? એ ઊંધું ન જાય તો ખાલી તમને કહું. Okay. So current will not go here. It will flow straight. If current doesn't flow here, how is that possible? એના માટે શું necessary? Resistance should be more or less. When does current not flow through something? When resistance is less or resistance is more? More. How much more? અહીંયા 40 ને બદલે 400 હોય તો current flow ન થાય? થાય ને, પણ ઓછો થાય. Correct or not? So 400 ને બદલે 4000 હોય તો flow થાય, પણ હજી ઓછો થાય. So stop ક્યારે થાય? When the resistance would become infinite. Suppose infinite. Then it means current doesn't flow there. So આ તો હોય કે ન હોય એનાથી કઈ ફરક નથી પડતો. Yes or no? Yes. Absolutely sure. Yes. So how much flow થશે? So how much is the current? 10, 2. એટલે આને જે હતું ને અહીંયા હતું 1 ampere. Clear or not clear? Yes. Sure. But basically this is ridiculous. If current doesn't flow here, આ voltmeter કે રીતે measure કરીને આવશે? આ કેના જેવું છે? vehicle માં speedometer નું dial આપ્યું છે પણ અંદર એનું કનેક્શન જ નથી તો ગમે એટલું ફાસ્ટ ચલાવો કેટલી સ્પીડ દેખાડે? Did you get that? So current is not flowing here. Only then it will show proper reading. If current doesn't flow here, only then it can show reading without error. But then there is another problem. If current doesn't flow, this will not work. Can voltmeter give zero error ever? No. Ammeter જેવું છે. યાદ આવે છે? કે નથી યાદ આવતું? Ammeter, if you connect it, always it will create some error because ammeter has some resistance. The voltmeter also always causes error because for no error required resistance is infinite. So you તો હોય નહીં અને એવું હોય તો આ વર્ક ન કરી શકે. બરાબર? Ideally okay, but practically it won't. સમજાણું? So what should a good voltmeter have? Low resistance or high resistance? High resistance. સમજાણું? Low ન હોવું જોઈએ. અહીંયા 1 મૂકો ને તો આ ઉપરથી જ જશે 99% એરર આવી જશે મને તો એવું લાગે. Okay. Why? If you take 1 and 10 in parallel is less than 1. Now let's not change everything. Okay, that's a bad idea. સમજાણું? The resistance will decrease so much you'll get a lot of error. Okay, so let's write down the same thing. Here the ammeter માં તો એક છે, but the opposite way. I mean, it has opposite meaning. It is for less error in measurement, voltmeter must have what? High resistance or low resistance? High resistance. Is that okay? For less error, the voltmeter must have high resistance. समझाणो કે ન સમજાણો? Sure. Okay. Ideal voltmeter will have how much resistance? Infinite. As infinite resistance. Ideal voltmeter has infinite resistance. Ammeter the exact ઊંધું છે બધું. ઓલું સિરીઝમાં લગાડવાનું, પેરેલલ. બરાબર ને? રેઝિસ્ટન્સ ઓલાનું લો હોય જાનું હાઈ. Okay? Everything clear so far? Let me present another very interesting problem. Do you remember? જો આ concept છે, જો તમને યાદ હશે તો તમને ખબર પડશે કે આ તો સમજાવી દે. બરાબર? If you don't remember what you have learned earlier, you are going to think, અરે આમાં કઈ છે જ નહીં, તમને ખબર. Suppose this is a cell. You know, all real cells have some EMF and have some internal resistance. Okay. Suppose I want to measure its EMF. What do I want to measure? EMF. Okay. What device have we studied that could measure EMF of a cell? Name one device that can measure EMF of a cell. Potentiometer. Voltmeter zero measure. What does voltmeter measure? Voltage. So EMF, isn't it a kind of voltage only? तो आम कनेक्ट करना हो तो आप मेजर नो करना क्या है?
सर आप सीरीज में कनेक्ट नहीं था. Voltmeter
parallel में कनेक्ट करो. Basically, if you want to find the potential difference between A and B, then you should connect it like this. So A and B वच्चे connect तो बराबर तो नहीं, connect तो बराबर करो नहीं. It will measure potential difference between A and B. जे બે point માં connect કરો એનો potential difference find कर लेते. That's it. So A અને B નો find करो ને આપણે. अभी दोनों था EMF measure. एरर तो બધા મેઝરમેન્ટ માં આવે પણ આવી રીતે કરાય કે નો કરાય તો કેમ નો કરાય કરીએ તો શું થાય
બેટરી નું રેઝિસ્ટર લો હોય
તો
વોલ્ટમીટર ને હાઈ રેઝિસ્ટર વોલ્ટમીટર નું રેઝિસ્ટર હાઈ
તો વોટ તારી પાસે એક જ પેન છે મારી પાસે ત્રણ છે તો બરાબર ને something has low value something has high value એવું કઈ નથી કે વોલ્ટમીટર requires high resistance
એરર જાજી આવે
એરર વધારે આવશે ઈ તો વોલ્ટમીટર નું પોતાનું રેઝિસ્ટન્સ ઓછું હોય તો એરર વધારે આવે બાજુવાળાનું રેઝિસ્ટન્સ ઓછું હોય તો બરાબર ને
terminal voltage find.
sorry
Sir, how to the terminal voltage find?
so you are saying that by doing this we find terminal voltage. Do you remember what is terminal voltage everyone? What is terminal voltage? Potential difference between positive and the negative terminal of a cell. So barabar hai. So this way we are finding terminal voltage. Like the EMF no measure tha.
Internal resistance battery na parallel na lage.
Internal resistance battery. What is it?
Internal resistor to series में connected है.
So what? કેની સિરીઝમાં આની સિરીઝમાં ને so if we measure like this so you are saying we are measuring terminal voltage between A and B अच्छा तो potentiometer માં क्या होता है yeah this is a potentiometer wire આ cell છે which you want to measure આમાં નતા કનેક્ટ કરતા do you remember this everyone ડાયાગ્રામ જો આટલી જલ્દી ડ્રો કરી શકાય તમારાથી થઈ જવો જોઈએ એક્ઝામમાં થઈ ગયો ને બરાબર છે ડાયાગ્રામ આ વાયર કેલોરીમીટર જોકી this cell so am I they aren't we really measuring between two different points like this so ये terminal voltage है you understand what I'm asking yes
સર આવી રીતે મેજર થઈ શકે એમએફ કે એમએફ માટે ઓપન સર્કિટ કન્ડિશન છે અને આપણે વોલ્ટમીટરમાંથી કરંટ 0 જ ફ્લો કરવાનો છે તો આવી રીતે મેજર કરી શકાય
for that resistance of voltmeter should be
પણ સર આપણે ઈએમએફ માટે ઓપન સર્કિટ કન્ડિશન છે
okay
અને વોલ્ટમીટરમાંથી આપણે કરંટ પાસ કરવાનો છે તો ચાલે છે
વોલ્ટમીટર માંથી આપણે કરંટ પાસ કરવો જ નથી ને
સર એનો નિયરલી 0 હોય તો જ એનો એરર લેસ આવશે ને
હા
તો સર એ રીતે મેજર કરી શકાય એમ
I measure કરી શકે આઈડિયલ કેસમાં રિયલ Simple. Column is very close to the correct answer. What is meaning of EMF? EMF is equal to terminal voltage when I is equal to 0. Yes or no? Yes है ना बताने? Open circuit condition means current flowing through the cell is 0. At that time, if you measure terminal voltage, that terminal voltage is actually EMF. Yeah, terminal voltage is actually EMF if current is 0. Okay or not? Everyone remember this?
Yes.
I need definition. Clear? Sure? But to use a real voltmeter, it will always need some current. A real voltmeter will always need some current. Obviously, सीधी बात है ना. Current flow no होता है suppose यहाँ. What does that mean? You have not connected it. So connect करने अगर measure થઈ જાય. No measure થાય ને. You get what I am saying? Yes or no? Sure. So connect करो तो आनु कहीं तो resistance हશે. So current will always flow. If current flows, what you are measuring, is it called EMF or is it called terminal voltage? It's called terminal voltage. Correct or not? If current flows, then the voltage that you are measuring cannot be called EMF. It has to be called only terminal voltage. The potentiometer may have a problem नहीं? Don't we have that same problem in potentiometer? Oh, null point. Do you remember? Potentiometer has null points. Yeah, they would. So we only do measurements of the null point. Do you remember that? The null point क्या है? यहाँ current 0. क्या है यहाँ 0. So whatever is the voltage between A and B, or between, for example, this point and this point. So the same as है ना? याद है भी theory? क्या नहीं याद?
Yes.
Voltage between A and B, which is terminal voltage, will actually be same as voltage between X and Y. But in this case, because current is not flowing, terminal voltage is actually same as EMF. So why does potentiometer measure EMF? Because you can use it even if current is not flowing. Open circuit. So why does voltmeter not work to measure EMF? Why does voltmeter not work to measure EMF? Because for voltmeter to work, current must flow, and if current flows, it's not called EMF. Is that okay or not okay?
Yes.
Sure. You see, these are two contradicting approaches. કાં તો EMF હોય તો કાં તો current હોય. બે તો ન હોઈ શકે ને. Voltmeter doesn't work without current. That means it cannot measure EMF. Make sense? Absolutely sure. So which device can measure EMF of a cell? Can you answer to? Potentiometer, not voltmeter, not in reality. Ideally, તમે એમ કહો કે this has infinite resistance, then it will be able to measure. That's what Colombo said. Is it okay or not okay? In reality, can a voltmeter measure EMF of a cell? No, never. Possible as well. Yeah, you can get an approximate value. For example, this R is very very high. Then current will be nearly zero. So I will do nearly say. Make sense? But not exactly. So it's not correct physically. Concept wise, such an okay. That you use the voltmeter to measure EMF. What you have really measured is terminal voltage, not EMF. Clear or not clear? कोई कुछ से तो याद रहता है which device is useful to measure EMF of a cell? Only potentiometer, not voltmeter. Practically नहीं. बराबर? Ideally कहीं तो कहीं, but ideal तो कहीं वही नहीं. So then, understood everything? इधर तो पोटेंशियोमीटर की जरूरत न हो. This is why. Suppose you could measure EMF with voltmeter. Terminal voltage तो measure થાય બે થઈ ગયા તો R મળી ગયું. પોટેન્શિયોમીટર ની જરૂરત નથી. Clear or not clear? Ammeter I measure कर लेते हैं. બધું લગાડ દો. So you have got the value of small r also from there. Sure. Never mind. So let's continue with this. So ideal voltmeter has infinite resistance, but voltmeter cannot be used to measure EMF unless it is ideal, which is never going to happen. Okay. Now, let's talk about errors in measurement. Okay. To reduce the error, the voltmeter should have high resistance or infinite theoretically. It was someone very. So how can we make it high resistance? So once again, there is an idea that we can convert a galvanometer into voltmeter. The galvanometer can be converted into voltmeter. How? Simple idea. By connecting a large resistance RS in series with galvanometer. By connecting a large resistance RS in series with galvanometer. How is this going to work out? Yes. Suppose this is the same circuit that we were talking about earlier. You remember this?
Yes.
Okay. And we want to measure voltage between A and B. Same problem. Again, what is galvanometer? Galvanometer is some device where if current flows, the needle will move. A and B is count. Okay. So if you connect just a galvanometer, I think I draw number. If you connect just a galvanometer like this, then there will be lots of problems. First, galvanometer resistance is high, but not that high which could make it a good voltmeter. Clear? Okay, so error तो आवे. Suppose आप 50 ohm है तो जोड़ता रहेगा. ना 40 वालों तो आपने calculate कर लो. You remember that? Yes or no? 10 માંથી 9.6 થઈ ગયું. બરાબર ને? 10 માંથી કેટલું થઈ ગયું? 9.6. Alright, so that was 4% error, wasn't it? Okay, not that bad, but not too good error. Okay, now so to reduce the error, what should we do? We should increase the resistance. So increase કરવા માટે series માં લગાડવું પડે. Do you realize that? Yes or no? Series માં કોની સાથે? Series to this 10 ohm? No, series to the હવે ammeter વાળું જો એકવાર પેજ પર. In ammeter, where did we connect extra resistor? In parallel. એને શું નામ આપ્યું હતું? Shunt. Is that okay? Okay or not okay?
Yes.
Right? We called it the shunt. It was connected in parallel and it was small. Here it's opposite. This is connected in series with the galvanometer and it's large. For example, 2 kilo ohm. For example, hello, 2 kilo. What will happen in this case? Current will flow, but a 2 kilo ohm અહીંયા છે. Suppose 50 ohm. The galvanometer's own resistance is 50 ohm. So at 2050. Is that okay or not okay? 2050 and 10 in parallel. કરો તો equivalent notebook માં 2050 2050 and 10 in parallel and equivalent to that. 2050 and 10 in parallel being equivalent to that.
2050 upon 206.
2050
upon 206. 9.95.
એટલે nearly 205 nearly 10 જ આવ્યું ને. Divide it. If you have calculator, divide it also and see what you get. 9.951. Okay. So, is this something like what you're getting?
Yes.
Okay. So, get error of it. This was supposed to be 10 actually, wasn't it? Theoretically, it was supposed to be 10. Don't put it there. Can I? Sure. And now it is 9.9. How much error is there? Very small. Change bow nano ayo ne? And why you change nano? Okay. So the error will also be very small. Make sense? So what is the purpose that this serves? By connecting a high resistance, what we are ensuring is that equivalent of this and this is nearly the same as this. આ 10 હતું ને એના બદલે કેટલું થઈ ગયું? It's nearly the same. અહીંયા આનો લગાડ્યો હતો તો 50 અને 10 નું equivalent શું આવે? 50 અને 10 નું equivalent શું આવે? કરો. It will be about 8 point something.
8.3.
How much?
8.3.
8 point. So you see there is a big change. આ તો 10 માંથી ખાલી 9.95 અને ઓલું શું થાય? 10 માંથી 8 point something. Considerable amount of change, isn't it? Make sense or not? I hope you do realize that compared to this change is quite big. A 0.05 change થયું ને આ 1.50 change. Big change. Clear? Okay. So that's the purpose RS serves. You can also think of it in another way. When this current I will come here, when this current I will come to the point A, where will more current flow? In the upper branch or in the lower branch? Lower branch. Why so? Because upper branch has high resistance. એટલે यहाँ तो negligible current જશે. And galvanometer will also be safe because galvanometer will burn if high current will flow. Is that okay? So by passing most of the current through here, we are achieving two things, two objectives. One, error remains small, and second, the galvanometer will not get damaged. So now, when both of these things are packed together in one box, this is what is called voltmeter. પછી એમાં જેમ એમીટર માં કેલિબ્રેશન કરેલું હોય એવું વોલ્ટમીટર માં કેલિબ્રેશન કરેલું હોય કે આટલો કરંટ ફ્લો થાય છે ત્યારે આટલો વોલ્ટેજ આવશે એન્ડ સો ઓન સો ફોર્થ. ઓકે, એટલે સ્કેલ બનાવેલી. So this is called voltmeter, right? So what is voltmeter made up of? You can say it's a galvanometer and then there is a resistance in series. This resistance will be large. So let's not be able to. Is it fine? Okay, anyway. So suppose this is RS, okay, and then there is G. અહીંયા ઓલું resistor હશે which we want to measure for. Okay, so do not worry too much about this. Do not worry too much about this. Do you agree that reading of this voltmeter, reading of voltmeter is VAB? VAB means what? Potential difference between A and B. This is voltmeter. Huh? Clear or not clear? This voltmeter is connected in parallel to this other resistance R જેનું આપણે measure કરવાનું. This is of no use for us. Focus here. આ બોક્સ ની અંદર ધ્યાન રાખજો, બાદ ને બોક્સ સાચું કરજો બધા. Okay. So VAB is V. reading of the voltmeter is V. Then do you agree that if current Ig flows here, why am I calling it Ig? Because this is the same current flowing through galvanometer. Then V should be equal to Ig bracket Rs plus G for resistance of galvanometer. There is a handy difference there. એમને માથું પર કેવું એવું લાગે છે મને સમજાણું શું કર્યું છે V equal to I into R. How much is the current Ig? Why are we calling it Ig and not I? Because this current is flowing through the galvanometer ultimately. Okay, so Ig multiplied by Rs plus G, because these two are in series. Okay, that will give us the reading of volt. Okay, open your textbook quickly. Chapter 4. Sum करायो एक પછી પૂરું કરો. Chapter 4 exercise last question. પરાણે કે એસાન કરતા કરતા આપી દીધા હોય ને એ બે ક્વેશ્ચન પૂછી દીધા ચાલો. બરાબર ને? Question 28.
Sorry,
No, sorry, 27. Excuse me. A galvanometer coil, આ લખાઈ ગયું ને એટલું. હવે એનાથી સમ કરીએ. A galvanometer coil has a resistance of 12 ohm. Whose resistance is that? G. G's value is given. 4.27 question है exercise 1. बराबर? G's value is given 12 ohm. And meter means galvanometer, shows full scale deflection. Full scale deflection means the needle turns all the way. बस હવે આગળ જવાની જરૂર નથી, જગ્યાએ નથી. Maximum current. So how much maximum current through galvanometer is 3 milliamp. Did you understand? Maximum current that can flow here is how much? 3 milliamp. So which value is given?
Ig.
Yes. So G is given in 4.27 and Ig is given 3 milliamp. Okay, what do we have to do? How will you convert this meter into a voltmeter of range 0 to 18 volts? So up to what voltage should it be able to measure? 18 volts. See this one. Here maximum current આવે તો maximum voltage આવે. Is that fine? Yes or no? Okay. So what should we do to convert the galvanometer into a voltmeter? We should connect something in series. RS. RS in series. So how much is that RS? We will find out. Let's put all values. How much is the voltage required? 18 volt. 18 volt is clear to you? 0 नहीं मुझे कोई. Sir 0 to 18 है मुझे 0 लेवल. Okay. So 18 is equal to Ig. એટલે આમ તો આને ફોર્મ્યુલામાં કન્વર્ટ કરી નાખો તો પહેલા થઈ જાય. RS is equal to V upon Ig minus G. Is this fine? RS equal to V upon Ig minus G. So what is RS? V 80 upon Ig 3 10 raised to minus 3. Don't forget milliamp. Minus galvanometer resistance 12. આવડી જશે ને?
હા.
કે નહીં આવડી જાય?
Nothing.
એટલે શું લખ નાખવાનું? To convert galvanometer into voltmeter, we connect a large resistor. How much resistance?
R.
How much resistance?
5988.
5988 ohm in series to galvanometer. Understood? Okay or not okay? જે આ સેન્ટેન્સમાં લખ્યું હતું ને એ લખ નાખવાનું, આન્સર નાખવાનું. Okay, by connecting a 5988 ohm resistance in series. I would say, okay, turns off.